decide whether the angles are alternate interior angles, same side interior angles, corresponding angles, or alternate interior exterior angles. So you have to just decide which type of angle it is. And you should be familiar with your angle types. So what are 2 and 7? Yeah, we call them the haters. They're as far away as you can get here. They're on opposite sides. You guys? Wait till it's quiet. Okay, they're on opposite or alternate sides of this transversal. That's how they get the name alternate in there. And exterior means they are outside of the parallel lines. So if these are my 2 parallel lines, Q and R here, outside of them would be above and below. Okay? If they happen to be going vertically, then outside would be to the right and to the left of them. Whereas interior would be in between the 2 parallel lines. So it's all in the name. Okay? So angles 2 and 7 are alternate exterior. And what about on number 2, 5 and 4? What kind of angles are 5 and 4? Okay, they're same side of the transversal, that's right. And are they exterior or interior? Interior. So we call these same side interior. Is this your favorite kind? Do you remember what we called those? Remember what we called those? They're the ones that are as close together as you can. They're part of different neighborhoods. They are. These are the lovers. That's right. Different neighborhoods, but they're as close together as they can be. All right. Number 3, 8 and 3. What kind of angles are 8 and 3? No. Nope. Not same side exterior, because then they'd have to be both outside. They're corresponding because they are in the same position. Okay? So they are in the same position. Corresponding angles. Okay. So corresponding angles. What about 6 and 4? Yep, 6 and 4 are alternate interior. What about 1 and 5? Also corresponding. Okay, so corresponding means if you were to take this vertex right here and slide it down over the top of this vertex, they would be in the same position. Okay, that's what corresponding means. You catch that? So if I took this vertex right here, where 1, 2, 3, and 4 are located, slid it down here, corresponding would mean they would be in the same position as 5, 6, 7, or 8. Okay? So are we okay with corresponding?
Yeah.
You think you need to know those 4 angle types? They'll be on the final. Okay? Wait, will what? All right. It says find the measure of all the numbered angles. Well, this problem number 6 amounts to either they're supplementary or congruent, right? So here I've got vertical angles that are congruent and then a linear pair which are supplementary, right? So all my angles are either going to be 180 minus 136, which is 44 degrees, or they're going to be exactly 136. So it goes like this. Next to the 136 is a 44 and a 44. Across from it is a 136. And then exactly the same pattern you see here is going to show up here. So what's angle 1 going to be? 44. And then you can work your way around. So angle 1 is 44. Angle 2 is 136. Angle 5 is 44. And angle 4 is 136. Okay. So there will be something like that on your test, kind of leading in up to the proof here. Okay, what about around here? Angle 1 is 85. And angle 2 is, yep, and then we got 85. And then what about angle 3? Angle 3 is also 85, and then angle 4 is, yeah, That's how it works. All right. Then I'm going to ask you to do a proof. Okay, I will ask you to do a proof on here.
No.
Yes. You think you're going to get away with that, having a final with no proof on? After doing proofs all semester? Well, the bad news is there's proofs on the final. The good news is, how many? There aren't a lot, I guess. Well, there are 50 multiple choice and 2 performance tasks. Both of the performance tasks have to be done. All right. Hey guys, we have mouse closed here while we're going through this. You know, talk about this proof. I think probably a lot of you need help on it, so I want to make sure we're paying attention. There will be a proof like this one on your final. That's why it's on the review. Okay. There's no secrets here. Not keeping secrets. You should recognize everything on the final. Anything you do, you will have done multiple times on tests, quizzes, performance tasks, in your notes, okay, on the review. So if you can do the problems on these reviews, you'll do well on the final. So here's a sample proof that involves parallel lines. It says supply the missing reasons. This is the type of thing you'll see in the multiple choice section. Okay, on the performance task section, you're going to have to, do the proof. There is a puzzle proof on there, so with some extra puzzle pieces. So you'll have to know what you're doing. Put together the proof. But here we have 1 is congruent to 3. Look at 1 and 3. This is one that's not starting with a given statement, right? What kind of angles are 1 and 3? Vertical. So it's a vertical angles theorem. Then we have our given statement. G is parallel to H, and I is parallel to J. Then we have angle 3 is congruent to angle 11. We'll cut. Okay, but corresponding angles are only congruent if the lines that they are corresponding angles of are parallel. So are they? Yes. So since G and H are parallel, 3 and 11 are congruent by the corresponding angles theorem. So you could write down corresponding angles theorem. Now, you've got to be careful with that, though, guys. Just because they're corresponding angles does not mean they're congruent. They have to be corresponding angles of parallel lines. Okay, it has to be corresponding angles of parallel lines. So I'll show you an example where students fall into a trap on the next page here. 11 and 16 are supplementary. If I and J are parallel, then 11 and 16 will be supplementary because they are same side interior angles. What's that? No, it's actually 11 and 16 are same side interior angles, and if the lines are parallel, the same side interior angles will be supplementary. We call that the same side interior angles theorem. Okay? And then finally, it says 1 and 16 are also supplementary. Well, what's happened from statement 4 to 5? Looks like something's been replaced, right? What's been replaced? Yeah, the 1 replaced the 11. We'll go back up here. It says 1 is congruent to 3, 3 is congruent to 11, so guess what? 1 is congruent to 11, so it's a substitution going on here. And that's it. Yeah, I'd take transitive, sure. It's kind of a, there really should be a statement here that says 1 is congruent to 11. That would be the transitive. And then in the next step, you'd say then 1 and 16 are supplementary by substitution. So there really should be kind of a statement in there. All right. Okay, on this next page, it says state which postulate or theorem you would use to prove that A is parallel to B. We have corresponding converse, alternate interior converse, alternate exterior converse, and then I told you to change this to same side interior converse because that's how it'll be referred to on your final. Okay, that's in our textbook. called consecutive interior angles, same side interior. It's either one. They both mean the same thing. So in this case, what we're doing is saying, okay, I know the lines are parallel because certain angles are congruent or supplementary. So that involves the converse theorem. So if you are proving lines are parallel, you should be using the converse theorem. If you're proving angles are congruent or supplementary, given that the lines are parallel, then you're just using the straight alternate interior angles theorem. There's no converse attached to it. Okay, so there's the difference. So which one is this on number 9? Yeah, alternate interior angles converse. And what about on number 10? What do we have going on? Corresponding converse, yep. And what in the world's going on 11? Yeah, same side interior converse. How do you know that? But it's more than that. It's not just that they're on the same side. What do they equal? 180. Okay, so you got to look for that. If one of these had been a 3 off, then you couldn't use the same side interior converse to prove the lines are parallel. Now, this is one where I saw a lot of mistakes on this problem. Okay, what's happening is a lot of you are looking at these lines, assuming they are parallel when they're not. We're trying to prove that they're parallel. They will be parallel, but you can't say that, for example, 3 is congruent to 2 in step 3 by corresponding angles. You can't say that because we haven't proven or been given that L is parallel to M. That's what we're trying to prove. Okay? So when you see a statement here that says L is parallel to M, you should be using a converse theorem in the end. Okay. In other words, if alternate interior angles are congruent, then the lines are parallel is what we're looking for here. So 2 is congruent to 1. That looks like it's given. How do I know 1 is congruent to 3? Okay, you can expect that on the final. Vertical angles. Now, here's the correct transition. 2 is congruent to 3 by transitive property, not by, yeah, it's not by corresponding angles. It's by transitive property. So what's the dead giveaway that you should be using transitive property?
If it goes in that order.
Yes, you're looking up above. 2 is equal to 1, 1 is equal to 3, 2 is equal to 3. When you see that, that is transitive property. You should recognize that. We've seen that a lot. What's that? Yeah, that'd be fine. Usually when we're talking about congruence of angles, we'll call it transitive. And substitution would be like when we replace something with something in an algebra expression or something like that. Either one I would take. I'd be thrilled with. So L is parallel to M. Why is that? Corresponding angles, converse. They're both theorems, but the converse says if the corresponding angles are congruent, then the lines are parallel. And if you're confused about whether this is the corresponding angles theorem or the corresponding angles converse, guys, you can just write it out. Say, if, I mean, what we're doing is we're going, if the corresponding angles are congruent, right, then the lines are parallel. The other direction would be, if the lines are parallel, then the corresponding angles are congruent. So don't confuse those. It's one of the things I'm testing you on the performance test. So any questions on that? Don't fall asleep on me. If she nods off, it's all And if Nicole's on that phone not doing calculations, and you...
That'd be the whole.
All right, so let's move into triangle congruence. Okay, that's the other performance test. It's triangle congruence. So here, pretty basic congruence. Here, proving triangles congruent. This is going to be a 3-stepper if you combine the given into 2 statements. So into 1 statement. Sorry, BC is congruent to DC, and AC is congruent to EC. That's given. Okay, look at this. 1, 2, 1, 2. So we have 2 out of 3 parts already marked congruent. We've got a bow tie here. So what's going to come down? Yeah, vertical angles. So I see a lot of students saying angle C is congruent to angle C, kind of confusing that idea of reflexive property versus vertical angles. I see 2 angle C's here. There's an angle C that is represented by angle ACB, and I'm going down the double dash to the single dash, and then I see another angle C that's represented by angle ECD. Okay, do you see those 2 angles? We should clearly mark them here and write down the reason why they're congruent. Vertical angles. That's the vertical angles theorem. So I have 1, 2, 3. I think I'm ready to prove these triangles are congruent. Okay, a pretty simple 3-step proof here. So triangle, and what I like to do is I've already thought about the order here, right? Just change the symbol then. So triangle ACB is congruent to triangle ECD by what? We've got an angle in between 2 sides.
Side angle, side.
Side angle, side. Yeah, you got to recognize that. There's a lot of that on the final. Okay.
A lot of side.
A lot of proving triangles congruent in the multiple choice on the performance task. Not side angle, side, but any of the congruence postulates or theorem. Okay. So we kind of start with that basic one. Then we're going to move to one that's a little bit harder here. So number 1 here, angle B and angle D are right angles. Also, we have AE bisects BD. That is given. So this is kind of debatable. I would probably be pretty lenient on this in a performance task, but B and D are right angles. We kind of have an understanding that that means they're congruent, right? All right angles are congruent. Some people might go ahead and state that. Some people might state angle B is congruent to angle D, and then some might not. They just go, well, it already said they're right angles. Right angles are obviously all congruent. Not going to be too much of a stickler on that. But this AE bisects BD, we do need to interpret that in terms of what's congruent. Okay? We can actually go about this proof many different ways. The fact that B and D are right angles would help us to use HL theorem if we want to. We could completely do that with this without HL theorem as well. The fact that AE and BD are bisect each other, we'll get these congruent and these congruent, and then we have vertical angles congruent, so you can skip the whole right angle thing and prove them congruent by side angle side if you want. That's what probably a lot of people would do. So yeah. Well, I've told you that we're not giving you things that you wouldn't use, but this one, there's different ways you could prove it. So in this case, you could not use that. But generally on these proofs, whatever you're given, you should probably use. But that's not necessarily true all the time. As you move, in the higher levels, you might be given information that you won't necessarily use on the proof. So we can decide how we want to go about this. Probably, did any of you pick HL as a way to prove this? You do. So a lot of you did SAS then, huh? Okay, so if I'm going to go about that, I can just skip the B and D thing. And I can say, okay, BC is congruent to DC. Let's mark it on the figure. And AC is congruent to EC by what part of the given? It's just definition of bisector, yeah. Definition of bisector. It's a segment bisector. That makes C the midpoint. If you said something about C being the midpoint, I'd take that. Let's go ahead and mark AC congruent to EC as well. And then this is just like the proof before. Step number 3, I can say angle ACB is congruent to angle BCE by vertical angles. There it is again. Vertical angles theorem. So mark those congruent. And now here it is again, another bow tie. Side angle, side bow tie. So triangle ACB is congruent to triangle DCE by side angle, side, and I'm done. Okay. Could I have used hypotenuse leg? Sure. Here's the hypotenuse, here's the leg, it's a right triangle. Okay, you could have gone that way. Could I have used angle, side, angle here? Sure, I could have used angle, side, angle. I could have even used angle, angle, side. Prove them congruent. You have all kinds of options on this. Actually, I like proofs like that, where you have lots of different options. But the process is the same. You're marking the triangle, getting 3 parts congruent. You can see them here, here, and here, and then stating why they're congruent. And once you've made your statements in terms of what parts are congruent, then you are limited on which one you can prove the triangle is congruent with. Okay. You're going to have a plan in place. All right. Finally, this last one on here is going to be a CP-CTC proof. So we're going to prove the triangle is congruent first, and then prove that other parts that we didn't already prove or say were congruent are also congruent. So it says ABCD, or ABCE is a rectangle, D is the midpoint of CE. Okay. Angle AED, let's mark it here, is congruent to BCD by definition of rectangle, or because it's a rectangle, those are right angles. Right angles are always congruent. Okay. Right?
Yeah.
So the angles are congruent here. AE is congruent to BC. Why is that? Besides being, like, definition of rectangle is kind of real general. But in a rectangle, we know that the opposite sides are always congruent, right? We know that's a fact for a parallelogram. So I've got side and angle here, right? She's yawning over here, making wise comments. I know. So number four. We haven't used the part of the given where it says D is the midpoint, right, Dan? So we have not used this part right here. It says D is the midpoint. So what's congruent based on D being the midpoint here? Not AB and BD. No, not necessarily. It's ED and DC, you're right. So ED is congruent to DC, and that's by definition of midpoint. Okay, now, why are the triangles congruent? And which triangles? Yeah, it's going to be a side angle side. Triangle AED is congruent to triangle BCD by side angle side. All right, finally, you should be familiar with this pattern. Prove the triangles congruent, then it says prove sides or angles are congruent. You know the last step on that? Yep. So very predictable, right? Last statement, reason is going to be CP-CTC. All right. Any questions on this?